participation today. The topic, low carbon considerations in construction, we've broken it up into 3 modules, which you saw probably in the invite. Module 1 is addressing drivers influencing low carbon considerations. Module 2 is identifying low embodied carbon solutions. Module 3 is wrapped around commercial and life cycle considerations. The context here, and let me just give some view of how we started. In discussions with JB&B and ourselves, part of our goal was to identify the opportunities of decarbonization in the construction industry. And it's founded on the understanding that the construction industry drives global emissions, and that achieving sustainability goals will only be possible if the construction industry plays a major role. And we see that initiatives to support decarbonization are gaining momentum both locally and globally. And it's founded in part on certain benefits. We feel that decarbonization initiatives can be cost effective, both in existing buildings and in new construction. And companies that embrace these initiatives will benefit certainly from consumer awareness and an enhanced ability to and focus from the capital markets. We believe that each player in the construction life cycle needs to support collaborative action, and that was kind of the foundation for Skanska and JB&B getting together in this context. So I'm going to ask our panelists to give a brief introduction to themselves, and then I will turn it over to Molly D from JB&B, who will be running this portion of the module. So Molly, why don't you introduce yourself?
Thanks so much. Yeah, great to be here today. Looking forward to discussing Module 1, which is going to be about drivers. To reiterate, my name is Molly D. Ramasamy. I am the Director of Deep Carbon Reduction at JB&B. And so my focus within the MEP space is about carbon reduction, primarily focused on operational, but really excited to be here today with the other panelists thinking about more holistically about carbon, both embodied and operational.
Thank you, Molly. And we also have Elaine Lai from Skanska as serving as panelist today. Elaine, why don't you briefly introduce yourself?
Hi, good morning, everyone. I'm Elaine Lai. I sit in the Portland, Oregon office, and I support the Green Project Solutions team, where we work with projects across all of U.S. building. I'll be presenting on the next module, Module 2, and then jointly presenting with Mark and Molly on Module 3.
Thank you, Elaine. And Mark, why don't you say hello to the audience?
Yes, good afternoon. I'm Mark Moore. I'm the Director of MEP Services for Skanska in our Boston office. And we focus primarily on operational details in getting buildings started up and running. So I will be speaking in the 3rd module with Elaine as well. And good afternoon.
Thank you, Mark. And I am Bob Lucky. I'm a Senior Vice President with Skanska. I lead our project planning services group in the Metro region, and I'm happy to have you all on board today. So I'm going to turn it over to Molly, and she's going to lead the discussions related to Module 1. And as I think, as Mike pointed out, there's a Q&A panel on the lower right. So if you click on that, I'll be monitoring that. And we hope to get some time at the end of the presentation to answer your questions. So, Molly.
Thank you so much. All right, let's go ahead and get started. I'll share my screen here. Hopefully everybody can see it all right. All right. Well, again, just want to say thank you for being here today to hear a little bit about the drivers that are influencing low carbon considerations in construction. I think this is an important collaborative effort that we're engaged here between JB&B and Skanska around, as Bob mentioned, kind of leaning into the trends that are happening around carbon in the built environment. And so the intent of today's presentation is going to be really to provide context, right? I'm going to be talking about those drivers across a number of different categories. And to give you a sense of what those categories are, we're going to start with a little bit of definition setting. We're going to talk about what carbon is in the context of the built environment. And from there, I'll dive into the drivers across policy, public opinion, technology, and then, of course, cost. hopefully we'll set things up such that the next two modules align with this one so that you really get a holistic picture of the conversation that's happening around carbon in really across the US. Much of my content today will be focused on New York, New Jersey, and a bit on Massachusetts, because that's primarily where I'm located. But of course, these trends are happening across the country. And so this is an important thing to be aware of, and glad to have you all here to learn about it with us. So to start things off, what is carbon and how is it generated in buildings? And there's actually a couple of different flavors of carbon as it relates to the built environment. I have a little graphic here on the slide that helps describe the two primary types of carbon emissions that we're going to be talking about throughout the course of this series of presentations. There's what's referred to as operational carbon, and this is the carbon that's released from the built environment in buildings specifically as a result of operating them, right? So buildings consume energy, and that energy that's consumed from the utility, whether it's electricity or natural gas or district steam in the case of certain places like here in New York City, there is a carbon content, a carbon impact associated with that energy use. So that's operational carbon, and that's my specialty. That's where MEP, mechanical, electrical, plumbing, typically comes into play. Now there's another flavor of carbon that is equally, if not more important, referred to as embodied carbon. And embodied carbon really covers the environmental impact that's associated with everything else in the building life cycle. Everything from extracting raw materials that are used in the construction of buildings, transporting them to manufacturing plants to create products, right? That's everything from cement, concrete, furniture, glazing for windows, again, transporting to sites, building buildings through construction processes, maintaining buildings over time, right? So when you actually get into a building, you have components of operational carbon and embodied carbon all the way through to a point at which a building perhaps is has reached its end of useful life and has to either be demolished, hauled away, and those components either taken to a landfill or hopefully recycled. So buildings have these entire life cycles, and what we're going to be talking about in these series of webinars over the next couple of weeks are these operational embodied carbon components, what's happening with them, and how we as service providers in this industry can help to support carbon-related goals and our clients as real estate moves forward within this context. So I just want to take a second more here and touch a little bit deeper on operational carbon. I mentioned that that's my area of expertise as somebody who's in the mechanical, electrical, plumbing, engineering realm. Elaine in Module 2 will really get into the details of embodied carbon and some of the tools and processes around that. But I often get the question, well, where does operational carbon really actually come from within a building? And the short answer, I kind of mentioned before, that it's around utilities, but operational carbon also has this heavy focus on on-site combustion, right? And in buildings, primarily what we're talking about on-site combustion, is heating. So I have a little graphic here. What it shows you is a building's energy end-use profile. I think this is actually based on a real building. And all of these different services, if you will, need to happen within that building. Just heating domestic hot water, comfort heating, right? So that people can stay comfortable. In certain typologies, humidification or dehumidification, cooling pumps, so on and so forth. You go down the line here, right? And so each of those end uses has an energy and carbon profile associated with it. In the case of heating energy, we're typically using a boiler, right? Could be furnace, something along those lines. Even district steam in places that have that. Those heating processes often have on-site combustion components that release carbon. So as we start talking about this more later on in the presentation, that's where what I'm referring to heavily when I talk about the operational carbon within a building. And the reason that these two things are so important, right, why we're spending so much time talking about them, and I think Bob really alluded to this very well, the building sector is a huge contributor of global emissions, right? They have a big impact, both the operational and embodied components. If you look at global carbon emissions by sector, the building sector is a big chunk. And then you can break it down even further, 28% for building operations, that's that operational carbon. And then an additional 11% on building materials and construction. It's also anticipated that the total carbon emissions of global new construction between now-ish and 2050 in a business as usual condition is quite substantial, right? 49% in the case of embodied and 51% in the case of operational. So this is a big nut to crack, right? These are things that we need to focus our attention on, especially as some of the drivers I talk about later on put pressure on the industry to address carbon contribution and contribution to climate change. So with that, I'm going to shift gears a little bit, and I'm going to start to actually talk about what the topic of this webinar is, the drivers, right? The drivers of low carbon considerations and the context in which all of this is happening. And the first one I'm going to touch on are policy drivers, right? And I think it's a good place to start because what we're talking about here are effectively mandates, right? Policymakers across the country that are coming out and saying, you know, putting a hard line in the sand and requiring building owners, construction folks, engineers to think harder about the contribution that buildings are making to climate change. So some high-level facts here. 32 states in the US right now have climate action plans, and those plans have all sorts of requirements in them. There's usually goal setting, targets, reduction targets as it relates to carbon across, you know, the entire industry, across the entire economy in these states. So you can see there's pretty broad support across the US for this idea of having a plan as it relates to climate. Now, 23 of those states also have carbon-specific policy. Now, there's a lot of different ways you can think about a building's contribution to the environment, right? You can look at it in the lens that we're looking at it, which is carbon, right? Environmental impact. But you could also look at it through other lenses. You could look at it through energy use intensity, for example. You could look at it through space functionality. There's a lot of different ways you can evaluate performance and contribution. And I think it's worth noting that carbon is the metric that's really kind of leading the way here. It's the one that's gotten ahead of the rest of the pack in terms of things to measure and compare for performance. We're also seeing the beginnings of what I'll call a shift to emissions-based metrics. There are 7 jurisdictions right now, New York City and Boston are 2 such jurisdictions that have building performance standards. And again, in those 2 particular locations, they're emissions-based standards. And what I mean by standards are, you know, real performance requirements for real buildings. Where the industry is kind of used to this idea of evaluating building performance in the design, sort of the early planning phases, right? And it's theoretical largely. More and more, we're shifting over to performance-based metrics where data is actually captured from buildings and used to determine how well that building is performing, whether it's against peers or relative to some particular standard or cap, which is the case here in New York City with Local Law 97. So again, this focus on carbon is becoming ever more apparent, and jurisdictions are starting to implement hard and fast rules that the industry needs to follow to minimize the impact of the built environment. I do want to take a moment and spotlight 2 particular, or really the 2, emissions-based performance standards. I just mentioned Local Law 97, which is a New York City local law. Very, very similar piece of policy out of Boston with BERDO 2.0. And what both of these performance standards effectively do is cap carbon on existing buildings. They have slight differences in how they're going to be rolled out. You know, for example, New York City is looking at buildings 25,000 square feet or larger, while Boston is focusing on buildings that are just a smidge smaller, right? 20,000 feet or tall or larger. They have different milestones in which caps are going into effect, but fundamentally these 2 laws are doing the same thing. And it's saying, okay, you know, at this point in time, buildings are required to emit no more than X number of tons per carbon dioxide equivalent. I think something that's also interesting about these 2 laws is that both of them have provisions to ratchet down over time, right? Which means that the targets that people are working toward today are going to be different 5 years from now, and they're going to be more difficult to obtain effectively. And so this has really disrupted the industry, right? It's gotten people thinking in a completely different way, innovating on design, innovating on investment strategy, innovating on construction and operation of buildings to maintain alignment with these new types of policy. And I would expect to see this rolled out more widely across the industry and across the US as the lessons are learned and the successes and failures kind of become evident in these 2 particular sort of first cases. So lots to look forward to, I think, to see what happens here and how it rolls out to the rest of the industry. Now, in terms of trends, taking a bigger picture view and not focusing on any one particular law, you know, the rate at which climate-related policy for buildings has been implemented has increased pretty significantly in the last 5 to 10 years. Perfect case study would be New York City. There's always been, I think, kind of a consistent movement toward energy efficiency and reduced climate impact in the city here. But in the last 3 to 5 years, the rate of policy coming down the pipeline has really picked up speed. The Climate Mobilization Act 2019, that was a whole new wave, a whole new package of laws around this particular idea focused on buildings, and we're just seeing more and more coming down the pipeline, right? A couple of highlights here. Local Law 95 is about building letter grade laws, right? It's a very public-facing, transparent way of showing how good, quote unquote, a building is performing relative to peers. Local Law 97, we just talked about, carbon caps. And then, of course, Local Law 154, if you're not familiar with this is actually a local law that bans natural gas in new construction with different timelines coming in the not so distant future. I mean, I think the first ones for multifamily residential are in 2023 and commercial in 2027. So those timeframes aren't far off in the distance. And again, this is causing the industry to think about what we do in a completely different way. Now, on the state level, there's also an interesting case study, I think, for New York. Not just the rate at which policy is coming, but also the kinds of policy that are coming down. You can see from the graphic I have here, everything highlighted in orange, right, is a recommendation that's been made to the state for policy around all electric coats, for example, or phase out of fossil fuel-based equipment. So thinking back to that little graphic I showed earlier of operational carbon and where it comes from, primarily from heating systems, right? There are very likely going to be laws coming from the state in New York that are phasing out things like boilers and requiring buildings to install electric, clean technology in the not so distant future, right? So those two trends, I think, are not just here in New York. I think they're in many different places: Pennsylvania, New Jersey, Massachusetts, California, of course, right? Can't forget the West Coast. This idea of a move towards all electric equipment, getting rid of those fossil fuel-based resources, and just expecting more and more faster pace of requirements. Now, those laws I just mentioned are really kind of focused on that operational carbon aspect. And I would say that operational carbon has been sort of the focus right now. But people are starting to recognize that operational carbon is really only part of the equation. There's that whole other part of the life cycle of that building dedicated to embodied carbon. And so some interesting stuff is happening on the policy front for embodied carbon. There are a number of policy mechanisms that are being explored in different places across the US. Things like procurement policies, the Buy Clean program is one such policy, building code requirements for low carbon concrete, for example, city planning, building ordinances. I mentioned climate action plans already, right? Some of them do have components that speak directly to embodied carbon impacts. And then waste management and circularity policies to make sure that we're not polluting more than absolutely necessary. So I think this is really encouraging, and I think the conversation around embodied carbon and the policy driving changes in this realm is going to follow a similar trajectory to the operational carbon, which is to say it's going to come faster, it's going to come stronger, and we're going to start to see the industry really respond in a big way. So now moving on from policy drivers over to public opinion drivers, right? We have policy, those are mandates, they're things that are required. But there's this whole other pressure in the industry that's coming from the general public. And why is that happening? You know, I think sort of the foundation of it is that climate science has become more clear, right? It's more highly publicized. And the latest sort of information coming from the IPCC is not great news. Global average temperature rise prediction is beyond what has been said is really the maximum that we could withstand without serious consequence. They're saying 2.7 degrees Celsius by 2040 in a business as usual condition, right? So the climate science is one part of it, but another really important part of it is how the media has kind of zoomed in on that messaging and how it's treating the information. You can see from the graphic on the right here, after that IPCC report came out recently, there was a wave of really sort of catastrophic, cataclysmic publicity and PR around the findings of that report. You can see it in the headlines, right? In the pictures and the imagery that's being used. And so those are the things that we as individuals in our homes watching the news every night are consuming. And what that's translated to are some interesting statistics, I think, in what the general public feels about climate change and what people and business and industry should do about it. You know, a majority of Americans think it's the most important issue facing society today. A lot of people think that it's a huge problem for the world, not just for the US. And this last one, I think, really speaks to what we're seeing in the building industry. 82% of Americans think that, you know, we should all do something, right? And so there's this pressure that's coming from the public about not just buildings. I mean, it's really everything. But remember, to that pie chart, buildings are a huge contributor to climate change. And so the focus is definitely there heavily. In terms of what businesses are doing, right? It's not just individuals. Fortune 500 companies, large real estate firms, investment firms, you name it, across the board, businesses responding by making commitments, right? They're kind of leaning into the challenge. So you have a quarter of Fortune 500 companies that have made some sort of public commitment to addressing carbon contribution, whether it's operational, investing related, embodied, right? The different scopes of emissions, people who are coming out with commitments either to carbon neutrality, right? Commitments to procure 100% renewable energy, using science-based targets to lead their strategies. And this is true, we're seeing this in real estate, right? You can see in some of the plans that are coming out of big real estate and development firms that these goals are in place and are going to be driving decision-making in the future, right? So $8 trillion worth of combined revenues and 18 million people combined across these Fortune 500 companies are somehow involved in this movement. I think that's really interesting and speaks to just again, the general direction that everything is kind of headed. Now, some people might think, okay, well, that all made sense prior to COVID, but what about COVID, right? Didn't that kind of detract from this whole movement in the building industry, from energy efficiency and carbon emissions reduction? You know, the short answer is no. In fact, I think people are even more sort of in tune with the idea that their health and wellness is often tied directly to how good, quote unquote, a building is. And that's how healthy that building is, how inviting it is, how energy efficiency and environmentally conscious it is. All of these things make up what an occupant perceives, right, when they enter a building. And so, again, some fun statistics. I always like to find this kind of information. There was a survey that was put out across the industry. And the question was, do you expect a significant increase in your tenants' demand for sustainable and environmentally friendly buildings, right? This was in the sort of in the dead of COVID, right in the crux of it there. And 83% of people who are in the real estate space, developers, building owners, operators, said, yeah, we expect a pretty significant increase in the demand for good buildings, healthy buildings and sustainable buildings, right? And so, again, I think that, you know, despite what's going on in the larger world kind of at large, this idea that we need to be better in the built environment is really sticking. And so what are we doing about it, right? The industry, the AEC industry specifically, has made commitments of its own. Of course, there's AIA 2030, it's focused on architecture and has requirements for embodied carbon by 2030, right? SE 2050, that's for structural engineers that are working toward net zero by 2050. And then MEP 2040 for professionals like myself, mechanical, electrical, plumbing engineers that are looking to commit to zero by 2040 with interim targets in 2030, right? So really across the entire suite of services provided in the AEC industry, construction included, we're seeing these commitments to getting to carbon zero, net zero, whatever you want to call it. By 2050 is sort of the latest. That's the benchmark that everybody cites for when all of this needs to be done by. Right, and you can see from World GBC that it's not just one or the other. There are commitments for both, right? Not just operational, not just embodied, but addressing both of them and paying them both enough mind and attention. There's also been an uptick, I would say, across the industry in voluntary sustainability programs, and those programs have slightly different flavors now that speak to this carbon requirement. Obviously, Passive House, you know, I'm seeing more clients on our side talk about Passive House and wanting to pursue at least the principles of it, even if they're not pursuing a formal sort of standard or certification. LEED 0 from LEED, right? So now there's a particular track for getting to carbon 0. And then a number of different sort of options in the Living Building Challenge. And again, I have seen clients recently that are pursuing these principles, even if they choose not to actually go for the certification, although some of them do decide to go for the certification as well. And so I think this just, again, speaks to how the industry is in many ways kind of leaning into this, seeing the signs, saying, okay, what can we do to get ahead of the curve, to be sort of the most desirable that we can be to tenants and building occupants and people who are going to live and work and play in the built environment. Now moving over to technology drivers. There's, I think, a lot of really cool and interesting stuff going on in the technology space, because objectively, decarbonization, whether it's from an operational or embodied perspective, it's hard. It's a difficult thing. There are technical challenges, not just with our materials and our products, but also with our processes, right? There's a lot that goes in, as we all know, to designing, planning, building, and operating buildings. It's not an easy thing to do. And so we need technology that's going to help us reach these goals, and we need stuff that's innovative. And I think we're seeing a lot happening in this area. There's a thing called prop tech. If you're not familiar with the term, it just refers to property technology, but it's this entire new sector that's really gained a lot of momentum. I don't know, I guess maybe in the last 20 years or so, even maybe last 10 years, dedicated to technology in buildings, right? Bringing together the Internet of Things with smart building technology so that there's more data, right? More automated functions in certain ways, right? If that's like automated alarms or fault detection, things of that nature. And between 2015 and 2019, there's been a huge increase in the investment in this particular sector. Venture capitalists are investing in this type of innovative technology that's all about buildings. Some of it is not necessarily about carbon emissions reduction. Some of it might be about indoor air quality monitoring. There's a lot of different things that are in this realm. But the point is, people are willing to put money to this, right? And find the solutions and deploy them in buildings in a meaningful way. Ton more deals. The sector has grown by over 1,000%, which is kind of crazy. So a lot happening here. In terms of what we're seeing in buildings rolled out for technology, there's obviously intelligent building solutions, and there's a lot of data, a lot of interest in capturing data and using that data for insights that can help building teams understand, how things might be better built, how they might be better designed, how they might be better operated. And so this Internet of Things sort of mentality is definitely getting traction in the industry. You can get great information on everything from who's in the building, how many people, at any given time, what the peak demand profile looks like in a building, which allows you to sort of determine when you want to operate things versus others to shift load and shift demand. Obviously, things like occupancy sensors to know if lights should be on or off. This is becoming more and more relevant, and I think it's going to be the standard more and more for what people are asking for as we go deeper and deeper into the carbon realm. For MEP, it's maybe not as neat as cool dashboards and sensors that are deployed throughout buildings, but there is still a lot happening in the realm of MEP for technology. And really the big thing is heat pump technology, right? It's not exactly brand new. Heat pumps have been around for a long time. In fact, chillers are heat pumps. But this idea of using heat pumps specifically for heating, right, as opposed to for cooling is kind of new and innovative. And, MEP engineers like myself and others in the industry are finding ways to integrate heat pumps, whether it's geothermal. In the New York environment, it's mostly air source heat pumps, right? But how to integrate them into tall, complex buildings. It's not an easy thing to do. And so we think there's going to be even more innovation in this area about the size of equipment, the performance of that equipment, which is already actually pretty good, believe it or not. Bringing down costs. All of this is going to be really important in the MEP realm as it relates to operational emissions reduction specifically. The whole point being to get away from those fossil fuel-based pieces of equipment like boilers and furnaces. So I think we'll see a lot more in this area as well. And then, taking all of these different kinds of technologies and all of these different solutions that exist out there and innovating around processes specifically to decarbonize buildings. And I do think this belongs in the technology realm, because just because you have the components doesn't mean you know how to put them together in a way that's going to effectively achieve the desired end. And that's where a number of different people in the industry are coming together to think about, okay, what are the innovative processes that we can use to take buildings to a decarbonized state? I like to use a framework called Reduce, Recycle, Electrify. I think the NYSERDA uses the term resource efficient electrification. There's a number of different ways of sort of describing this, but the idea that you can deploy things around energy efficiency, technology around building intelligence, right, to reduce energy. Then there are innovative concepts and technology that's coming that's going to support heat recovery, right? So the idea of, instead of throwing heat away in a building, reusing it, that's going to be part of the equation. We call that recycle. And then, as I mentioned before, heat pumps, right? Different clean electrified technologies that can be used in place of fossil fuel-based resources to electrify buildings, primarily heating end uses. Now, it's worth mentioning here that there is a really critical component, and I'm going to get into this a little bit in maybe 2 sections, about the grid, right? Because I always get questions at this point about, like, well, you say it's clean on electric technology, but isn't electricity dirty? So we're going to talk about that. I am going to address it, but the short answer, yes, it is really important to kind of do this whole thing within the context of a decarbonized electric grid. And that's why I have that little graphic off to the right there. Now, obviously, that's not a comprehensive overview of all the technology. As I mentioned, Elaine's really going to dive into embodied carbon. So most of what I just showed you was focused around that operational component, but stay tuned in Module 2 for more cool, interesting technology and processes for embodied carbon management. But now I'm going to shift over to cost drivers, which I think is one of the most interesting areas to understand as you start thinking about how this fits into your day-to-day, whatever your role may be. I think understanding sort of the cost implications of this whole thing is super important, because we all know that cost is a big component of decision making. So I'll start with a little bit of background here. Electricity, which is effectively the future for operational carbon, right, of our buildings, of the built environment here. Right now, it's still generated with fossil fuels. So this is getting back to the last slide where I said I was going to get into this. I'm kind of getting into it now. We call that brown electricity. And the reason that there's carbon associated with that is because electricity is generated through the combustion of fossil fuels, right? It's typically natural gas, in fact. So as you sort of generate that electricity, you're emitting carbon into the environment. That will not necessarily be the case in the future, and we're seeing broad scale support for decarbonization of the electric grid across the entire US. It's very, very heavily focused here in New York, big efforts on the state level around that. But the reason that I'm telling you about this is that the cost of electricity over time has been coupled to the cost of natural gas, because the input fuel is natural gas and the output is electricity, right? So you can see from the graph here on the right that over time, electricity has been more expensive than natural gas, but they follow the same trajectory, right? When you have a bump in the natural gas price, you have a bump in the electricity price. Obviously, volatility is a concern. And so somebody might look at that and say, well, why would I transition my building over to an electrified solution, right, if it's going to be so much more expensive and the grid right now is still quote unquote dirty, right? And those are good questions. The answer to those questions is that, one, the grid is not going to be dirty forever. There are serious efforts to green it. But two, when we stop creating electricity with natural gas or other fossil fuel resources, the cost of that electricity to generate it is going to fall, right? So there's going to be this decoupling of electricity prices from natural gas prices. So in the future, we might have a situation that looks like this, right? A building, this building I showed before, right, little graphic here, that is taking advantage of energy reductions through that reduce, recycle, electrify framework, right? Whether it's intelligent building innovations, MEP innovations, innovations in embodied carbon or construction practices, they're going to be taking advantage of energy reductions. And then they're going to be electrifying, and all of those electrified end uses are going to be run on clean, renewable electricity, right? Whether that's solar, wind, hydro, it counts as well. Nuclear is technically not renewable, but it is zero carbon. Obviously, there's more conversation about that around safety and whether or not nuclear is going to be a big piece of the pie in the future. But the point is, this is what we're working toward, right? And bearing in mind that when we decouple that electricity generation from natural gas, the cost is going to come down to generate that electricity. Why is that? Why would the cost come down, right? I mentioned the volatility of natural gas already, right? And generally, the cost of natural gas has been increasing over the last however many years. But more importantly, it costs more to build and operate a fossil fuel-based power plant than it does to build and operate a renewable generating plant. So from an economics perspective, if I'm a developer of projects like this for generation in the electricity sector, it doesn't make sense for me to invest in new fossil fuel generators. It makes sense for me to invest in new renewable generators. That bodes well for this idea of the grid greening over time, which in turn bodes well for the idea of buildings electrifying and thereby eliminating their operational carbon impacts by using clean renewable energy. If you're not convinced with that argument, just sort of talking about it high level, the economics and the dollar values, dollar per megawatt hour of generated electricity, they don't lie, right? And so we can look and we can see all of the different generating resources over time for the last 10, 15 years, 2009 to 2019. And your traditional generating resources that create electricity, things like gas plants, nuclear plants, coal, and combined cycle gas, right? They've decreased a little bit over time, but, have stayed relatively consistent. When we look at renewable energy instead, you can see we have huge drops in cost, start high and low, right? Onshore wind, huge drops, solar, and all of them, for the most part, are below the cost of generating for those quote unquote traditional fossil fuel-based resources. The numbers are 89% for solar electricity over the course of 10 years, and a 70% reduction for onshore wind. Offshore wind is gaining traction right now. There's a lot happening in New York around offshore wind. Still a little bit high on the levelized cost of energy, but expected to come down as well. And so if there's a lot of skepticism, understandably, around whether or not the grid will green, whether or not that will happen in a cost-effective way, right? We're feeling a lot of that skepticism in New York, for example. But I think at the end of the day, if you really look at these numbers, this is sort of inevitable that this would happen because it is more cost effective for developers in the power sector to invest in these renewable projects than it would be for them to necessarily take on the additional risk of investing in something that could become a stranded asset. So this is an area of sort of discussion that doesn't get discussed as much. I wanted to share it with the team here because I think it's like a bigger picture item that really is going to drive a lot of what happens in the building industry, even though it's focused primarily on the power sector. I think an interesting parallel to what I'm talking about here, because it might seem a little bit out there, this whole electricity generation piece and how it fits into operational carbon. I think an interesting parallel is the electric vehicle market, right? Similar thing where, obviously natural gas powered or gasoline powered cars were operating at a certain level of competitiveness, and then electric vehicles came in, they were very expensive, but then the technology evolved very quickly. We're seeing that evolution of technology right now in the building industry with PropTech, right? All of that additional investment. In the EV sector, that cost has dropped pretty significantly and is expected to continue to drop, so that electric vehicles are either at parity or less expensive than your sort of traditional combustion-based engine vehicle. I think we are going to see and are already starting to see exactly the same thing happening in the built environment as was seen in the transportation industry. An interesting fact too, and just thinking about kind of what's happening in the geopolitical realm of things right now, there's a lot of volatility around energy. Energy independence is something that is being talked about pretty heavily at this point in time. And that is just another sort of component of the argument for the move away from fossil fuel-based resources and toward clean, electrified, renewable resources. So I think I landed, so this is good. We have about 15 minutes left to talk questions. and kind of have a discussion here. But thank you for listening to my spiel here about all the different components that are factoring into this. And I suppose we'll open it up for questions now.
And Molly, thank you very much for that. That was wonderful. So we do have one question. The audience is being a little shy, so I'll start there.
Sure.
Question: does Local Law 97 mean that we will go all electric for all mechanical equipment for heating and cooling?
So yes and no. Local Law 97 is pushing buildings to electrify everything. That's kind of what it wants you to do. And I think new construction, absolutely, all electric is going to be the way to go. But existing buildings are pretty challenging, and there's certainly sort of a balance point of electrifying over a time horizon in a way that's practical and makes sense in the context of existing buildings. So I wouldn't be surprised to see, 90% electrified heating and cooling end uses, and maybe 10% for, either peak shaving or just because an end use is particularly hard to electrify. I'm thinking of the hospital and healthcare industry, for example. I'm always apprehensive to talk in all or nothings, but yes, to reiterate, it wants all electric in existing buildings. Reasonably, there'll probably be a little bit of fossil fuels just because it's really hard to get all carbon out of buildings. But that's what we're shooting for.
No, thank you for that. And while we got another question. I noticed in one of your graphics, fans take up a significant portion of a building's energy use. Has that evolved over time as other HVAC related costs go down? And can you explain more?
Sure, yeah. So the graphic I showed in my slide was actually just data from one particular building. I believe it was a healthcare building. But fan energy doesn't necessarily take up a big chunk of the pie across the board. Obviously, fan energy is a place to potentially focus attention if it is kind of larger. I would say in a commercial facility, it probably is slightly different there and isn't as much of an opportunity as it would in that particular building that I had modeled.
Okay, thank you for that. We don't have any current questions. I think while we're waiting, oh, here we go. Look at that. The carbon emissions during the construction of a building would be classified as operational or embodied?
Good question. So primarily it would probably be embodied carbon, but there would be some operational components. So for example, if you're running equipment as part of your construction processes, that could probably get bucketed as quote unquote operational because it's energy that's being consumed by whatever that equipment is. But largely in the construction phase, we're talking about embodied, the materials, the transportation, the content of the cement or concrete, all of that would be embodied.
Great. Thank you for that, Molly. So while we wait for additional questions, I want to cycle back on something that Molly mentioned in her presentation, and it's the skepticism of the greening of the grid, right? A lot of people are out there thinking that, we're going to wait decades for any real movement there. I want to just offer at least one example of something that's happening right now, right? Molly mentioned offshore wind, which is definitely going to be a focus in New York moving forward. There are several wind farm concessions that have already reached agreement and deals have been signed. One company in particular, I won't mention the name today, but is out with a request for proposal, or short to be request for proposal, for starting to construct their facility to both build and maintain their operations off the shore of Long Island. So it is coming, and it's coming right now. And so it's a pretty cool turn to see that become a reality. Okay, Molly, we have one question. Can solar/wind output realistically match the output needed? In other words, is there space limitations or transmission restrictions that make renewables unable to meet the same demand fulfillment as coal or gas?
Great question. So in terms of at the building level, right, in New York, in a dense urban environment, really in general, something like solar for on-site, really difficult because of space constraints. Thinking more broadly at the utility level, right, utility level solar, obviously wind falls into that category, both onshore and offshore. Definitely the capacity factors are different, right? And they're not as dispatchable as coal or natural gas. There's always a concern about the quote unquote intermittency of renewable energy. That being said, those problems are hopefully solved with large scale utility storage, in which case we could store energy and then dispatch it much more easily. And then keep in mind that not all energy that's produced by the utility sector will be renewable. Some of it will likely come, well, it'll be renewable, but not intermittent renewable. Hydro, for example, which makes up a large part of our mix here in New York, is something that isn't a concern from that particular perspective, the intermittency. It's really the solar and wind that is a concern. So yeah, you bring up a good point, which is that, you know, if the sun doesn't shine or the wind doesn't blow, what do you do? And the answer to that is battery storage, and that's something that they're focused very heavily on, both in the power sector. And now there's a lot of movement from the building sector too, because buildings are saying, well, if I'm going to sign up for this idea of renewable energy, I need to know that my grid is going to be resilient.
Yeah, thank you for that, Mike. And there's a wonderful parallel there. Again, it's another example of forward thinking. Most people in New York are probably aware of a lot of the aviation work that's gone on in the past, 5-6 years. The JFK redevelopment is a perfect example of, the kind of that forward thinking. Terminal 1 aspires to be energy neutral through solar. And if you think about a terminal building, there's a lot of roof area. And their solution is basically to generate what they feel is enough power, either between what they can generate for use at the point or what they can store in batteries so that they can decouple from the grid if they had to. There also probably an interim solution with them where they will use fuel cells to potentially make up some of the difference in high peak demands, but their aspiration is to be completely off the grid if they can and generate all their own power. So it's an interesting study, and looking forward to seeing how they solve that. So I don't see any further questions. We'll give it another minute, and appreciate the engagement from our participants. Does anyone have any further questions for Molly at this time? And if we can't get to, oh, here we go. Battery storage is something that has always been challenging to do given cost and capacity. Have you seen any technological advancements that are in development that will exceed current expectations?
Yeah, absolutely. There's a lot of movement in battery storage right now. Different chemistries, I guess I'll call them, different combinations of chemicals that are being explored specifically for battery storage, both at a building level and at the grid level. The battery storage and renewables operate on what's called a learning curve, which means that over time, people get better at developing them and the technology evolves. And as a result, the technology becomes less and less expensive, right? And so there is expected to be quite a drop off in cost associated with battery storage, and an increase in the technology and innovation around that particular area, especially since it's the answer to a lot of questions around the grid.
Okay, thank you, Molly. We have another question regarding electrification. So the question is, electrifying existing building stock is expensive. What financing programs exist, or how can government best assist?
Great question. I'm glad you brought it up. I probably should have added a slide about incentives and rebates and different clever financing mechanisms. So in terms of financing projects, right now in New York, we're getting ready to, well, they've already rolled it out, but it hasn't had a ton of traction just yet, but PACE financing, property assessed financing mechanism, which actually kind of takes the cost of projects and makes an additional kind of line item on your tax bill, and it transfers with the building, right? So that kind of solves the issue for a lot of developers that have short hold periods, right? They can still invest in whatever the upgrade or the electrification project is, get it financed, and then that financing goes with the building if they sell it. So PACE financing is one mechanism. And then in terms of incentives and just government support, there's a lot of money out there, both for organizations like the New York State Research and Development Authority, NYSERDA, to do studies for technical analysis. There's a lot of money out there for the utilities to provide rebates for clean heat. So for example, here in New York, Con Edison has a big pot of money that they're giving out for clean heating and cooling solutions. In fact, I think just this morning there was a project, I won't say which one, but it achieved, I think, over $700,000 worth of rebates for heat pumps, right? So that money is out there, and if you know where to look for it, the government is definitely incentivizing people to take this on, because I think they do realize that it is expensive. Right now, with electricity still coupled to natural gas, right, electricity per kilowatt hour is pretty expensive, right? 5 times more expensive here in New York than it is to just, combust natural gas in your boiler. That being said, right, if you think about that whole levelized cost of energy series I did on how the cost of generating electricity is dropping, once the transmission and distribution sort of challenges are overcome, hopefully we'll see a leveling off of those electricity prices. And then in a perfect world, in theory, they would also kind of decrease over time. Of course, the time horizon there is certainly in the distance. But that is why it's really critical to reduce energy first, right? You don't want to just electrify everything as it exists today in an existing building. You have to be kind of clever and smart about it. You want to reduce, recycle, then electrify.
Thank you for that, Molly. Another question has come in. Innovative solutions can often be met with resistance. Go figure. In your opinion, what stakeholders will play the largest role picking up the torch and being champions for sustainable and more resilient buildings?
That's a great question. I really think that it's going to be first adopters in the real estate community, because they're the ones that are going to have to take on the most risk, right? And they're kind of hedging their bets against how desirable their buildings as an asset will be to tenants, to the general public, so on and so forth, right? There's value there that they're kind of counting on, and I think that it will be achieved, but they're the ones who are demonstrating that this can be done. And I think really that's what the industry needs, is they need demonstration. And once we're able to demonstrate it, then I think more people will start to come around to the idea of, okay, I've seen it here, I feel comfortable giving it a try in my building, but it'll take some time.
Yeah, no, we agree wholeheartedly with that, Molly. We've seen it with some of the largest developers in New York, understanding that clean, resilient, sustainable buildings are more attractive to tenants and more attractive to financiers. So it's interesting that the private side has realized that this is beneficial, and they are pushing forward with it. So that's a very exciting outcome.
Yeah, and I would say too that another important stakeholder, I mean, really one of the most important is us here on the call. Because if we're educating our clients, right, on the value, to Bob's point, on what people are asking for, what we're seeing, what the technological solutions are, then they're in a better position to make those decisions and kind of lean into the whole thing instead of putting the brakes on. But we don't have to do that. And so I think we as service providers are playing a really important role when we step up and we say, yes, we believe that this is both doable and can be financially advantageous for you. And here's everything you need to know to make a decision, right? I think that's important too.
Thank you. We have another question. Are you aware of any studies related to cost and potential timeline to do mass building retrofits?
Yes. So in the New York context, the Urban Green Council did look at sort of the market value of the retrofit. Well, I'll say the retrofit market value as a result of Local Law 97. I think the number was in the 20 billion range. It was somewhere around there. So big numbers, certainly. And I think it's going to depend, the cost is going to depend too on how quickly people move, right? If people start now, then the cost is going to be more manageable to them. We are absolutely going to have a shortage of labor in this whole retrofit market, designers, engineers, construction personnel, right? We're going to be so busy, it's going to be ridiculous. And so the longer people wait, the more expensive this whole thing is going to become.
Looks like we have time for one more question, Molly. So
Sure.
a bit off topic. If electric vehicles become the majority of vehicles, how much more demand would that be?
That's a good question. I don't know the numbers off the top of my head. I think they are published probably in the different utility long-range plans. So, for example, in New York, you can look up the New York Independent System Operator, and they publish reports about exactly this kind of thing, where they model what the outcome will be on demand for the grid if you had wide-scale adoption of EVs. I don't know for electric vehicles what that number is, but I think the question here is kind of getting at a very legitimate concern, which is around infrastructure and the stress on infrastructure that will come as a result of wide-scale electrification. And to that, I would say that the utility is planning for those eventual futures, right? And so there's going to be increases in capacity that come along with the expected demand increases for wide-scale electrification.
So I misspoke. We have another question. Actually, this one's interesting because it goes back to some thoughts that we've worked at with JB&B on at some point. Molly, you mentioned battery storage. Are you starting to see any other forms of energy storage systems making a comeback, i.e. ice plants?
Yeah, absolutely. Thermal storage is, I would say, a key concept that we're exploring, that we've talked to the Skanska team about, that we're talking pretty widely about in the industry right now. We actually have a pretty fun video called Ice Heating that we just published. Maybe I'll send it around and we can send it to the participants here. But yes, thermal storage is important because it allows you to flatten demand and also shift load around. By doing that, you can take advantage of times on the grid when the carbon intensity is low. Additionally, there's a cost play, right? That's where ice has traditionally been used to manage demand costs by shifting load around. But you can use it for heating, believe it or not. It's counterintuitive. That's what the video is about. But yes, we're definitely seeing a comeback on thermal storage.
Okay, thank you, Molly. So out of respect for everybody's time, we're nearing, well, we're at 1 o'clock. So we have another question which we will attempt to answer everyone's questions. There's probably one more left that we'll respond to. But again, on behalf of Skanska and JB&B, I want to thank you all for participating today. I think one of the key messages we'd like to drive with this group is that this level of decarbonization, this level of aspirational energy reduction and moving to clean grids is not going to happen. It's not going to happen if just the builders are behind it or the design teams are behind it. It's the entire construction ecostructure has to collaborate within this to make this successful. And we think that we're seeing the interest now, very excited about where this is going within our industry. Our industry has the largest impact, and I think we are poised to be the leader here. So we thank you all for participating today. We look forward to your participation and your insights and questions in modules 2 and 3, and hopefully we will see you all in module 2 next week. So thank you all very much. Have a great day.
Thanks, everyone.